Implementation of asteroid mining technologies by 2027, for critical phases in $3.8 billion investment strategy for sustainable resource extraction. Date, January 31, 2025. Theme, Technical Overview of Asteroid Mining Development. Executive Summary. The ambitious initiative to implement asteroid mining technologies by 2027 is poised to revolutionize resource extraction and address material scarcity on Earth. This project, structured around 4 critical phases and backed by a robust investment strategy of $3.8 billion, aims to leverage the untapped resources of asteroids for various industries. The following report outlines the key phases of implementation, investment strategy, and overall expectations for the future of asteroid mining. Key phases of implementation. 1. Research and Development 2023 to 2024. The first phase centers on extensive research to develop the necessary technologies for asteroid mining. This involves identifying suitable asteroids, utilizing advanced telescopes and data analytics to identify asteroids rich in valuable materials such as metals, water, and rare earth elements. Robotic systems development, creating autonomous robotic systems capable of operating in the harsh conditions of space. This includes designing robots for resource identification and extraction. Spacecraft engineering, developing spacecraft equipped with advanced propulsion systems to reach targeted asteroids efficiently. 2. Prototyping and testing 2025. The second phase involves building and testing prototypes of mining equipment in low Earth orbit (LEO). Key activities include demonstration missions, conducting technology demonstrations to validate extraction processes and assess the performance of robotic systems in microgravity. Operational methodology refinement, refining operational methodologies based on test results to ensure effective resource extraction once missions commence. 3. Deployment and Operations 2026. Once testing is successfully completed, the focus will shift to deploying mining missions targeting specific asteroids identified during the R&D phase. This phase entails launch of mining missions, initiating the first mining missions to extract materials from selected asteroids. Resource extraction operations, implementing extraction processes to gather materials such as water for fuel and life support as well as precious metals for industrial applications. 4. Scaling and Commercialization 2027. The final phase involves scaling operations for broader commercial use and establishing partnerships with industries that will benefit from asteroid-derived materials. This phase includes commercial agreements, forming partnerships with aerospace companies, technology firms, and manufacturers to secure a market for extracted resources. Supply chain optimization, developing an efficient supply chain for transporting resources back to Earth, including considerations for regulatory frameworks and market readiness. Investment strategy. The $3.8 billion investment strategy is critical for the successful implementation of asteroid mining technologies. Funding will be allocated across various areas including technology development. Significant resources will be directed towards R&D and engineering efforts to develop cutting-edge mining technologies. Mission planning. Investments will cover the logistical and operational aspects of planning missions, including spacecraft design and launch logistics. Operational costs. Ongoing operational costs during the deployment of mining missions will also be part of the financial strategy. Funding sources are expected to include a mix of private investments, government grants, and collaborations with established aerospace companies. Sustainability and resource scarcity. A recurring theme across multiple sources emphasizes the importance of sustainability in asteroid mining. The initiative aims to minimize environmental impact while maximizing resource gains by tapping into asteroid resources. The project seeks to alleviate resource scarcity on Earth, particularly for materials that are increasingly difficult to obtain due to overextraction and geopolitical tensions. Challenges and considerations. While the roadmap to asteroid mining is ambitious, several challenges must be addressed. Technological hurdles. Developing reliable and efficient mining technologies capable of operating in space presents significant engineering challenges. International cooperation. The nature of space exploration necessitates collaboration across nations to establish regulations, safety protocols, and share technological advancements. Economic viability. The economic implications of asteroid mining must be carefully considered, including the potential impact on existing markets and industries. Timeline of events. 2023, commencement of the R&D phase with a focus on technology development. 2024, continued advancements in mining technologies and spacecraft engineering. 2025, prototyping and testing of mining equipment in low Earth orbit. 2026, initiation of initial mining missions targeting selected asteroids. 2027, scaling operations and beginning of commercial resource extraction. Conclusion. The vision of implementing asteroid mining technologies by 2027 represents a groundbreaking step towards sustainable resource utilization. Through a structured approach involving research, prototyping, deployment, and commercialization, this initiative promises to unlock the vast potential of space resources. With strategic investment and a commitment to sustainability, asteroid mining could significantly alter the landscape of resource extraction and contribute to a more sustainable future for humanity. The implementation of asteroid mining technologies by 2027 is structured around 4 critical phases. Backed by a substantial investment strategy of $3.8 billion aimed at sustainable resource extraction. Here is a detailed breakdown of the information provided regarding this ambitious endeavor. Key phases of implementation. 1. Research and Development 2023 to 2024. This initial phase focuses on extensive research to develop technologies capable of identifying, analyzing, and extracting resources from asteroids. This involves creating advanced robotic systems and autonomous spacecraft designed for deep space operations. Counterintuitive information. While many may assume that the technology for asteroid mining is already developed, the emphasis on R&D highlights that significant innovations are still required. The public perception might lean towards an overestimation of current capabilities in space technology. 2. Prototyping and Testing 2025. Following the R&D phase, the focus will shift to building and testing prototypes of mining equipment in space. This phase includes technology demonstrations in low Earth orbit (LEO) to validate extraction processes and refine operational methodologies. Counterintuitive information. It is often believed that testing can be conducted in simulated environments on Earth, but the necessity of actual space testing underscores the unique challenges of space operations which cannot be fully replicated on Earth. 3. Deployment and Operations 2026. Once testing is complete, the next step will involve deploying mining missions targeting specific asteroids identified during the R&D phase. Operations will commence with the extraction of materials which may include water, precious metals, and rare earth elements. Counterintuitive information. While asteroid mining might seem straightforward, the complexity of targeting specific asteroids and the operational challenges of extraction are often underestimated. The logistical considerations of space missions add layers of complexity that are not commonly appreciated. 4. Scaling and Commercialization 2027. This phase involves scaling operations for wider commercial use, establishing partnerships with industries requiring these materials, and optimizing the supply chain for resource delivery to Earth. Counterintuitive information. The assumption that once mining is established it will be easy to scale operations is misleading. In reality, the transition from pilot projects to commercial viability often faces significant regulatory, technological, and market challenges. Investment strategy. The $3.8 billion investment is earmarked for technology development, mission planning, and operational costs. It is expected to come from a mix of private investments, government grants, and collaboration with aerospace companies. Counterintuitive information: many may think that the cost of asteroid mining would be significantly lower due to advancements in technology. However, the reality is that the initial investment is substantial due to the high risks and uncertainties associated with space missions. Common key points: sustainability focus. Emphasizing sustainable practices is a recurring theme with a strong need to minimize environmental impact while maximizing resource gains. Resource scarcity. The potential of asteroid mining to alleviate resource scarcity on Earth is highlighted. This suggests a future where terrestrial resource extraction becomes less viable, contrary to the common belief that Earth resources are limitless or easily accessible. Differences between sources. Some sources stress the technological challenges and the necessity for international cooperation, while others emphasize the economic implications and market readiness for such ventures. Varying timelines are presented regarding the feasibility of commercial operations, with some suggesting that 2027 might be overly optimistic. Counterintuitive information. The public often perceives space mining as a straightforward extension of current mining practices. However, the divergence in expert opinions about timelines and challenges indicates a complex landscape that is not fully understood outside specialized circles. Timeline of events. 2023, R&D phase begins. 2024, continued technology development and spacecraft advancements. 2025, prototyping and testing of mining equipment in LEO. 2026, launch of initial mining missions targeting selected asteroids. 2027, scaling operations and beginning of commercial resource extraction. Conclusion. The ambitious goal of asteroid mining by 2027 encompasses a well-structured plan involving technological innovation, significant investment, and a vision for sustainable resource utilization. The timeline and phases reflect a comprehensive approach to addressing both the challenges and opportunities presented by this frontier in space exploration. The counterintuitive aspects reveal a nuanced understanding of the complexities involved in asteroid mining, suggesting that while the vision is compelling, the road to successful implementation is fraught with challenges that may not align with public expectations. The actualization of this vision will require careful navigation of technological, regulatory, and market dynamics that are often underestimated. The report on the implementation of asteroid mining technologies by 2027 presents a comprehensive outline of the project's critical phases and investment strategy. While it covers the essential elements, there are several important aspects that may be overlooked by readers which hold significant implications for the future of resource extraction and sustainability. 1. Technological feasibility and innovation gaps. One crucial point that may be overlooked is the discussion around the technological feasibility of the proposed mining technologies. The report emphasizes the need for advanced robotic systems and autonomous spacecraft, but it lacks a detailed exploration of the current technological gaps that must be addressed. For instance, the development of robust materials that can withstand the harsh conditions of space radiation, extreme temperatures, and microgravity is critical. The significance of this lies in the fact that without addressing these technological challenges, the ambitious timeline of 2027 may not be achievable. Moreover, innovation gaps in artificial intelligence and machine learning for navigation and operation in deep space are pivotal for mission success. 2. Regulatory and legal framework. Another important aspect that the report does not delve into is the regulatory and legal framework surrounding asteroid mining. The Outer Space Treaty of 1967 and subsequent agreements provide a general framework but lack specific guidelines on resource extraction. The implications of these legal uncertainties are profound, as they could hinder investment and international cooperation. Furthermore, how the international community chooses to regulate these activities will play a significant role in shaping the future of asteroid mining. Addressing these legal aspects is significant because it could either facilitate or obstruct the planned operations affecting everything from funding to international relations. 3. Sustainability beyond resource extraction. While the report highlights sustainability as a recurring theme, it primarily focuses on minimizing environmental impacts during resource extraction. However, it overlooks the broader implications of sustainability in the context of space exploration. For example, how will the extraction of resources from asteroids affect the sustainability of space environments? The significance of this is twofold. First, it raises ethical questions about the long-term impacts on celestial bodies. Second, it prompts the need for a more comprehensive understanding of how to balance resource extraction with the preservation of space ecosystems. This aspect is essential for fostering a responsible approach to space resource utilization. 4. Economic viability and market readiness. The investment strategy of $3.8 billion is a substantial figure, yet the report does not adequately address the economic viability and market readiness for asteroid mining. It touches on partnerships with industries but fails to explore the actual demand for materials expected to be extracted from asteroids. Understanding the market dynamics, including potential competition from terrestrial mining and fluctuations in material prices, is vital for predicting the success of these ventures. The significance of this lies in the necessity for a solid business case to attract further investment, which is critical for the project's longevity. 5. Public perception and engagement. The report does not consider the role of public perception and engagement in the success of asteroid mining projects. Public interest in space exploration has historically been high, but concerns about ethical implications, environmental impacts, and the prioritization of space resources over terrestrial needs can lead to significant pushback. The importance of this issue lies in the potential for public sentiment to influence funding, regulatory decisions, and the overall trajectory of the asteroid mining initiative. Engaging the public and addressing their concerns will be crucial for building support and ensuring the project's success. 6. Interdisciplinary collaboration. The report highlights the need for collaboration with aerospace companies but does not emphasize the importance of interdisciplinary collaboration across various fields such as environmental science, economics, and ethics. The challenges of asteroid mining extend beyond engineering and technology. They require input from diverse expertise to create a holistic approach to resource extraction. The significance of interdisciplinary collaboration is paramount because it can lead to innovative solutions that address both technological and ethical challenges, ultimately paving the way for sustainable practices in space. 7. Potential for space economy expansion. While the report outlines the resource extraction from asteroids, it underplays the potential for the broader expansion of the space economy. Asteroid mining could catalyze additional industries such as space transportation, space tourism, and even in situ resource utilization for future missions to Mars or beyond. The significance of recognizing this potential is that it can attract a broader range of investors and stakeholders, fostering a more integrated approach to the development of the space economy. Conclusion. In conclusion, while the report on asteroid mining technologies presents a structured plan for implementation by 2027, it is essential to consider the overlooked aspects that hold significant implications. Addressing technological feasibility, regulatory frameworks, sustainability, economic viability, public perception, interdisciplinary collaboration, and the potential for space economy expansion will be crucial for the success of asteroid mining initiatives. Ignoring these factors could lead to challenges that undermine the ambitious goals set forth in the report, making it vital for stakeholders to adopt a holistic and informed approach as they move forward in this frontier of resource extraction. 1. For critical phases of implementation. The structured approach, consisting of 4 critical phases: research and development, prototyping and testing, deployment and operations, and scaling and commercialization, provides a comprehensive roadmap for the ambitious goal of asteroid mining by 2027. Each phase builds upon the previous one. emphasizing a systematic progression from foundational research to operational execution. Research and Development 2023 to 2024. This phase is crucial as it lays the groundwork for technological advancements. It focuses on developing the necessary tools and systems, including autonomous spacecraft and robotic mining equipment, which are essential for the success of subsequent phases. Prototyping and Testing 2025. The transition from R&D to prototyping is a pivotal moment where theoretical concepts are tested in practice. Conducting tests in low Earth orbit (LEO) will help identify potential operational challenges and validate technologies before full-scale deployment. Deployment and Operations 2026. This phase marks the shift from development to real-world application. As mining missions are launched to target specific asteroids, the operational phase will be critical for demonstrating the viability of asteroid mining as a resource extraction method. Scaling and Commercialization 2027. The final phase aims to establish asteroid mining as a sustainable and commercially viable industry. It involves not just the extraction of resources but also creating a robust supply chain and partnerships with terrestrial industries, thus integrating space resources into the global economy. 2. Investment strategy of $3.8 billion. The proposed investment strategy of $3.8 billion is a key element that underpins the entire asteroid mining initiative. This financial backing will be essential for various aspects of the project, including technology development. A significant portion of the investment will be directed toward R&D efforts to create advanced mining technologies. This investment is vital for overcoming the technical challenges associated with operating in space. Mission planning and execution. Funding will also cover the costs associated with mission planning, including the logistics of launching spacecraft, conducting mining operations, and transporting resources back to Earth. Collaboration with aerospace companies. The investment strategy highlights the need for collaboration with established aerospace companies, which could enhance the project's credibility and leverage existing experience in space missions. Sustainability focus. The strategy emphasizes sustainable practices in resource extraction, which is increasingly important in today's environmentally conscious landscape. This focus not only addresses potential criticisms but also aligns with global sustainability goals. 3. Sustainability and resource scarcity. The emphasis on sustainability throughout the asteroid mining initiative is a pivotal point for discussion. As Earth faces increasing resource scarcity, the potential of asteroid mining to provide alternative sources of materials is significant. Key aspects include minimizing environmental impact. The initiative aims to minimize the ecological footprint of resource extraction, contrasting sharply with traditional mining practices on Earth, which often lead to severe environmental degradation. Abundant resources in space. Asteroids are believed to contain a wealth of materials, including water, precious metals, and rare earth elements, which are essential for various industries. This abundance could alleviate resource pressures on Earth and create new economic opportunities. Strategic advantages. Accessing space resources may provide strategic advantages in terms of securing supplies of critical materials that are becoming increasingly difficult to obtain on Earth. This could enhance national security and economic stability. Driving innovation. The focus on sustainable practices could drive innovation in technology and processes, setting a new standard for resource extraction industries both in space and on Earth. 4. Technological challenges and international cooperation. The technological challenges associated with asteroid mining are substantial and warrant detailed discussion. Key points include complexities of deep space operations. Developing the technologies for identifying, analyzing, and extracting resources from asteroids involves navigating complex challenges, including the harsh conditions of space-long communication delays and the need for autonomous operations. Need for international cooperation. The scale and complexity of asteroid mining necessitate collaboration among nations and private entities. International frameworks for governance, resource sharing, and technological exchange will be crucial for successful operations. Economic implications and market readiness. There are differing opinions on the market readiness for asteroid mining. While some sources argue that 2027 may be an optimistic timeline for commercial operations, others stress the potential economic benefits and the readiness of certain industries to engage with space resources. Regulatory and ethical considerations. The introduction of asteroid mining raises questions about ownership rights to resources and the ethical implications of extracting materials from space. Establishing clear regulations will be important to guide the development of this new industry. In conclusion, the ambitious goal of asteroid mining by 2027 is a multifaceted endeavor that hinges on technological innovation, substantial investments, sustainable practices, and international collaboration. Each of these points offers rich avenues for in-depth analysis and discussion, highlighting the transformative potential of this frontier in resource extraction. 1. Gold Rush of 1849. The California Gold Rush was a significant event in American history where thousands of prospectors flocked to California after gold was discovered at Sutter's Mill. This influx of miners led to a rapid population increase in the region and the establishment of mining towns. The rush not only spurred the economy but also highlighted the challenges of resource extraction, including the impact on the environment and indigenous populations. 2. The iron and steel industry in the 19th century. The Industrial Revolution brought about a massive need for iron and steel, leading to the development of extensive mining operations in places like Pennsylvania and later the Mesabi Range in Minnesota. This period saw significant technological advancements in mining and resource extraction processes, including the introduction of steam-powered machinery and railroads which facilitated the transportation of raw materials. The transformation of these resources into finished goods played a crucial role in shaping modern economies. 3. The space race and lunar missions. The Cold War-era competition between the United States and the Soviet Union led to the space race, culminating in significant technological advancements aimed at exploring and utilizing space. The Apollo program, particularly Apollo 11 in 1969, not only demonstrated human capabilities in space exploration but also laid the groundwork for future discussions about resource utilization in space, including the potential for mining lunar resources. The technological innovations from this period have parallels to current asteroid mining endeavors, emphasizing research and development, prototyping, and operational deployment in extreme environments. Future outlook. Implementation of asteroid mining technologies by 2027. Offering a sustainable alternative to terrestrial mining and potentially alleviating resource scarcity on Earth. The implementation of asteroid mining technologies by 2027 is structured around 4 critical phases and backed by an investment strategy of $3.8 billion aimed at harnessing the vast resources of asteroids. Here's a detailed outlook on the anticipated developments and implications of this endeavor. 1. Research and Development 2023 to 2024. The initial phase, which commenced in 2023, focuses on extensive research and development. This phase will see significant advancements in technologies needed for identifying and extracting valuable materials from asteroids. Key areas of focus will include advanced robotics and autonomous systems, development of robotic systems capable of operating in the harsh environment of space. These systems will be designed to perform tasks such as surveying asteroids, conducting in situ resource utilization (ISRU), and executing mining operations autonomously. Deep space navigation. Innovations in navigation technologies will be crucial to ensure spacecraft can accurately reach and maneuver around targeted asteroids. Resource mapping and analysis, utilizing spectroscopy and other remote sensing technologies to analyze asteroid compositions from afar, thus identifying the most promising targets for mining. 2. Prototyping and testing 2025. Following R&D, the focus will shift to prototyping and testing innovative mining technologies. This phase is critical for validating the theoretical concepts developed in the first phase. Key activities will include Testing in low Earth orbit (LEO). Prototypes of mining equipment will be tested in LEO to simulate asteroid conditions. These tests will help refine extraction processes and operational methodologies, ensuring technology readiness for deep space missions. Collaboration with aerospace companies. Partnerships with established aerospace firms will facilitate access to technical expertise and infrastructure, enhancing the testing process and reducing risks associated with technology validation. 3. Deployment and Operations 2026. With validated technologies, the next phase will involve the deployment of mining missions targeting specific asteroids. This phase will include selection of target asteroids. Based on data from the R&D phase, specific asteroids will be identified for mining operations, focusing on those rich in water, rare earth elements, and precious metals. Execution of mining missions, launching spacecraft equipped with mining technology to conduct extraction operations. This will mark humanity's first attempts at resource extraction from asteroids, setting a precedent for future missions. Data collection and operational learning. Continuous data collection during operations will be essential for improving extraction techniques and informing future missions. 4. Scaling and Commercialization 2027. The final phase will focus on scaling operations and establishing a commercial framework for asteroid mining. Key activities will include partnerships with industries. Developing partnerships with sectors such as technology, construction, and energy that require the materials extracted from asteroids. These partnerships will be vital for creating a sustainable market for space mined resources. Establishing supply chains. Creating efficient supply chains for transporting mined materials back to Earth, ensuring that the resources can be effectively utilized in various industries. Regulatory framework and international cooperation. Addressing the legal and regulatory challenges associated with space mining. Necessitating international cooperation to develop a framework that governs resource extraction in outer space. Investment strategy. The $3.8 billion investment strategy is critical for the success of asteroid mining. Funding will be sourced from a combination of private investors, government grants, and collaborations with aerospace companies. This financial backing will be allocated towards technology development. Significant portions will be dedicated to advancing the necessary technologies for successful asteroid mining. Mission planning. Costs associated with mission design, launch, and operational execution will be covered under this strategy. Sustainability initiatives. Investments will also focus on ensuring that mining operations are conducted sustainably, minimizing environmental impacts both in space and on Earth. Conclusion. The ambitious plan to implement asteroid mining technologies by 2027 represents a groundbreaking shift in resource extraction paradigms. By focusing on sustainability, technological innovation, and international cooperation, this initiative holds the potential to unlock vast resources that could significantly benefit humanity. While challenges remain, the structured approach outlined in the 4 critical phases positions the endeavor for success, paving the way for a new era of space exploration and resource utilization. As we move forward, the outcomes of these efforts will not only impact industries on Earth but also shape the future of human presence in space.